Good afternoon. Thanks a lot for joining the session today. My name is Iosif Itkin. I am co-CEO and co-founder of Exactpro. Our focus is providing software testing services to financial market infrastructures, mostly exchanges and clearing houses. Today I'll talk about two things: about using AI in software testing, about using synthetic data and limitations of using synthetic data, and also about limitations of using AI in such a process as software testing. Not everyone cares about software testing, but more people do care about technology. Essentially, whether it is regulatory change, users involving needs, or competitive pressure, companies have to invest heavily in their technologies to stay ahead of the curve. Software platforms rapidly become the most valuable asset in most of financial and other organizations. And the complexity of the systems that we operate are constantly growing. So technology represents a very substantial investment for most of the companies. Warren Buffett said, "Never invest in a business you cannot understand." And without understanding your technology, it is very difficult to justify that investment. And the process of understanding technology is called software testing. Software testing is an information service that provides information about technology. And building or operating software without thorough testing is like devising a military strategy without having proper intelligence, or treating patients without accurate diagnostics, or participating in electronic trading without access to market data. So software testing can be important. Software testing at a glance can be described in 3 steps. First, we make decision of which actions to take and in which order, in what order. Then we execute these actions against the systems or services that are important for us. And then we are trying to interpret the output of our experiment. So the middle part, executing actions, often called test automation, and it is the most simple thing because it is completely mechanical. On the other hand, deciding which actions to take, generating test ideas, requires cognitive workload, and it is the task of medium complexity from a cognitive perspective. The task of interpreting the outcome of experiments also requires cognitive workload, and it is more difficult task, so it is a hard task from implementation perspective. So it is well known that generative AI is capable of producing lots of data, and the task on the left, deciding on the actions, can be easily solved with generative AI. There is a single trend that affects most of modern business, is that the growth of volumes of digital data and also computational capabilities enabled us to use machine learning, sub-symbolic AI, to deliver improvements in any industry. The idea is that it is possible to use the same trend in software testing, in running empirical technical exploration of the system. And the first candidate for that is the test idea generation. So there are 2 things that are required for machine learning to be efficient is computational capabilities and enough data. So computational capabilities, you just need to spend enough money on the test environments. But the test data, there are two possible ways. First one is to get real data. The second one is to generate synthetic data. The difference between real data and synthetic data is that the real data is related to the real world, and most of the time it has real value. So somebody would like to steal it, to sell it, etc. So the real data, to understand the value of the real data, you can look at the business of any modern stock exchange and compare how the business lines related to data behave in comparison to any other business line. You will see that in most of exchange groups, data services are growing by double digits every single year. On the other hand, all other business lines can behave differently. And it is true for every sector. So real data has value and has associated costs. Synthetic data is something that we can produce in virtual environment. And Exactpro, we do quite a lot of work in producing synthetic data. And this work was even received some awards from Swift Sibos hackathons previously. So I will share the main idea that we use internally during synthetic data generation. The idea is to use the simplest possible format, machine-readable format, to keep this data. And this allows to decrease the cost of data analysis and processing. Modern AI can process pictures, process text, process software code, but the amount of electricity that is required to process data in more complex format is higher. So as an environmentally conscious company, we are trying to organize everything in the simplest format possible. So we look at protocol specifications and turn them into CSV files. We look at data captures, network data captures, convert them into CSV files. Every artifact that we produce is in CSV files, and it is to decrease the volume of computational capacity required to deal with it. Once we simplify it, it is possible to do quite a lot of synthetic data generation, and the process most of the time look this way. We take some source piece of data, and then we start modifying it. So we modify it, modify, and in the process, we also annotate all produced pieces of data to be used in the test model. But the main aspect of synthetic data and synthetic models is the quality of the synthetic data. The quality of synthetic data and test data or test scripts are not an exception. Can be measured across 4 dimensions. It is fidelity, utility, privacy, and explainability. So fidelity is how closely synthetic data represents real-world data. So I've already mentioned that real-world data is something that you can put a price tag on. So having something that look alike can also have additional value. It is fidelity. Utility is whether we are able to use synthetic data for any purpose. So Real data has value. Synthetic data only has value when we can use it to get information about the real world. In particular, if we can use synthetic data to find information about defects, defects is something that decreases the value of the software for the good stakeholders or increases the value of the software for the bad stakeholders. So if synthetic data helps us to detect and describe defects, it has utility. In software testing, utility might be more important than fidelity. So if you can use the data to successfully solve some problem, it is more important than having data that is realistic. Still, there are scenarios, for example, in non-functional testing, when we are replaying operational day and we would like to get some latency measurements, fidelity of the data might also be important. Privacy, it is how responsibly we are using the data. So real data has value, has a price tag. So it is possible to violate trust of the partners, clients, etc. So it is very important that synthetic data takes a responsibility, and we take responsibility of dealing with synthetic data, not to leak sensitive information. And the last one is explainability. So how easy it is to explain the data and make conclusions. And humans brain operate two systems, system 1, system 2, so conscious and unconscious system. And the conscious system, one of its key characteristic is that it has very limited throughput and very limited capacity. So in dealing with any large volumes of data, we need to take care of explainability and make sure that we can cut this data to the volumes that system 2 in human's brain can process. So these are also qualities of any good model. It is mapping based on reality, pragmatic, has utility, and the main one, reduction. So we can reduce the data that it can be explainable for the humans. So it is necessary to use discriminative models to cut data and to take pieces of it. So when we try to use synthetic data in any process, we need to have two models. One is generative model, and another is discriminative model. So the first one produces lots of data, and the second one reduces lots of data to the maintainable volumes. And this brings us to almost to the last slide. So can machine learning be used in testing? So there are three parts: execution, data generation, and data interpretation. So modern large language models and other AI systems are prone to hallucinations and errors. And somebody can say that these hallucinations and errors are not a problem, but rather creativity is a feature of creativity. So for data generation, having hallucination in the model is a good thing. On the other hand, on the right, when we are trying to interpret large volumes of data, we are more constrained in what we do. So in interpretation, we need to separate things between whether they increase the value of the software or decrease the value of the software. Value is always subjective to the humans. What is one man's treasure means nothing for another people. So in order to assess value, a system or a creature needs to have empathy in order to judge what is important for humans. So if we do want to have a system that will be able to do things on the right, we need it to have empathy. And also it needs to make sound judgment on whether it is increases value or decreases value. And making judgment about value requires responsibility. And also, in order to run this process again and again, we need to have reliability. So there are 3 features that the system should have: empathy, responsibility, and reliability. And machine learning AI has none of these 3. And that's why it is the only thing that you can do with machine learning on the right is to calculate the weight function when it makes sense to call humans to help. So we do know that humans have limited capacity in System 2, so we need to decrease their workload. And it is very important to calculate this function and do it properly. On the other hand, most of you work with the large teams, and you know that humans also are not always good in responsibility, reliability, and even empathy. So what is the difference? The difference is that over the last 1,000 years, we learned how to deal with this fact. So we do know that humans are not reliable, not responsible, and sometimes do not have empathy. But what we also know that it is possible to reason with them. They also feel pity, remorse, and fear. So it is possible to scare humans in acting responsible. It is not possible to scare AI in acting responsible. So in order to use machine learning AI in software testing and in any other business area that requires responsibility, it is necessary to split the activity in 2 parts. 1, calculate the threshold when you need to call a human, and then have humans capable of acting responsibly. So in Exactpro, we are able to do it across 20 countries, across many different business areas. We apply this approach to stock exchanges. It is probably the core of our business, where we first generate lots of data, then we pass it through the system, and then we are building data analysis procedures that will trigger humans to take actions where necessary. We apply the same approach in post-trade, clearinghouses, depositories, payment systems, and also this approach can be used in banks or in any other area that has high criticality, lots of data, and ability to produce lots of synthetic data, execute it, and to analyze it. So thank you very much. We do have information about this approach of using AI to deal with complex financial market infrastructures and of building digital twins as discriminatory model to deal with large volumes of synthetic data. Thank you. Thank you very much. Thank you.